Okay, so let's deal with those kind of questions when we have a force that is applied onto an object with mass 4.65 kilograms that is at rest, and the magnitude of force net and the displacement or the distance is shown as in the graph. First, let's find the equation of the graph for this part here where the graph is going up. So as we have mentioned, first we'll find the slope, and the slope is, the formula for the slope is delta y over delta x. Whatever is delta y in our case will be the change of force or the change of displacement, and this will be the change of force is the force final minus force initial over d final minus d initial. Since force final and d final are the initial force initial and d initial are equal to 0, then this will be positive 20 over 10 and as positive 2. And if we are going ahead and finding the units, will be 2 newtons per meters. Now, and the point of it is part of the line is 0, 0. So therefore, the equation of the line will be y equals plus 2 and x. And if we write it in terms of the force, will be a force as a function of distance will be equals to 2 times d. To find the speed that is at 6.41, first we'll find what is the force at d equals 6.31 meters. So we'll substitute as positive 2 times 6.31, and this will be positive 12.62 newtons. So 6.41 is somewhere in here, and the magnitude of the force is positive 12.62 newtons. Now, the area under the graph will be the change of momentum or the impulse. The area under the graph, since it is a triangle, will be 1 over 2 base times height, or 1 over 2 times base is 6.31, times height is positive 12.62, and this will be positive 39.8161 newtons times distance in this case. And force times displacement, which is the area under the graph, is equal to the work from physics 20. Now, the work based on the conservation or work and energy principle is equal to the change of kinetic energy. Initial kinetic energy is equal to 0 because it is starting from rest. So the work that is positive 39.8161 will be equals to 1 over 2 mass of the object times final velocity to the power of 2. From here, we can find that the final velocity is equal to the square root of 2 times positive 39.8161 divided by mass that was 4.65. And as a value will be 4.14 meters per second. And now, if we are going to calculate momentum at that moment when it is moving as 6.31 meters will be mass times velocity, and this will be the final velocity, so it will be 4.65 times 4.14 and times 4.65 equals to 19, of course positive, 19.2 newtons times seconds or kilograms meters per second. The second part of the question is asking for the speed when we are when the object is moving 14.01 meters. So we'll have this graph here, 10 meters here, and then it continues in a straight line. 14, let's suppose that 14.01 meters is somewhere in here, and this is positive 20, this is force. So now the area that is from 0 to 14.01 is this shaded area here, which is as a result of the area of the triangle plus the area of the rectangle. And the area of the triangle is 1/2 base times height, and the area of the rectangle is base times height. So for the triangle, base is 10, so it will be 1/2 times 10 times the height is positive 20 plus base of the rectangle, which is this one here, from 10 to 14, which is 4.01 times positive 20. So the total area after you enter it in your calculator will be 180.2 newtons times meters, sorry, times meters, not distance, times meters. Then this is equal to work, and it is positive, yes, 180.2 newtons times meter, and it is equal to work, which based on the work energy principle is equal to change of kinetic energy. And since it is starting from rest, it is equal to kinetic energy final, which it is 1/2 mv final squared. So v final will be the square root of 2 times 180.2 divided by mass, so that was 4.65. Enter it in your calculator. You final velocity is 8.80 meters per second. And if we are calculating momentum at that moment, at that point, will be mass times velocity, which will be 4.65 times 8.80 times 4.65 equals to 40.9 kilograms meters per second. This is how you approach those kind of questions.